All right, thank you guys for joining us today. We're super excited to be launching our temperature dashboard, which is, I think, more of a revolution when it comes to the science of urban heat. We've been working really hard to democratize the use of temperature so everyone can use it. And that's why we built a temperature dashboard for everyone, whether they're engineers or they're not engineers. And we're going to demonstrate how everyone could benefit from this. I think for a very long time, and this is what we guys have been working on for all of those years, is to prove that all of this industry, when it comes to advisory and taking years to collect urban heat data 2 meters above the ground, which is not weather data, um, uh, has been a very broken industry because it takes so much money and time to be collected and then analyzed and then obviously visualized, and let alone that at FortyGuard now we're gonna demonstrate how we can bring this data to everyone, right? To the fingertip of everyone's use. So I'm super excited to be here. For the audience, my name is Jay, and I've got Snehal, Adam, and Amir with me from the technical team, and we're super excited to be launching the dashboard. So Adam, what do
Yeah.
you have to tell us?
Cool. So we'll start off with the technology. I'll tell you guys a little bit about the technology, and then we'll dive into the product demo right away. So at the core of what we're building, it's what we call as the temperature operating system. It's a foundational model that powers essentially everything that we do. Um, it's designed to process, analyze, interpret temperature data at a very granular level. And essentially, the whole idea is so that we can make it more accessible and actionable for different applications. On top of this is what we have our temperature API, which just basically serves as a bridge between uh, the temperature operating system and the different products that we have. Today, the product that we'll be discussing about is the temperature dashboard. It's a front-end application that helps us visualize this data that comes from the temperature APIs.
Nice.
So yeah, let's just jump into the product demo then. The very first thing that the user sees is the map of the US. So again, now our application is available for everyone in the US to use.
Beautiful.
So we'll be doing a demo right now. So we start off right again with creating a heat map. So I'll leave it to Snehal to discuss more about this.
Yeah, sure. So one of our main goals was not to just make the dashboard functional, to make it intuitive as well. Because like
Nice.
it might be the user is the engineer who wants to analyze city heat trends within the city itself, or it's a normal user who wants to just analyze their neighborhood and want to see what are the more hotter areas and the cooler areas within their neighborhood itself. So
To buy a house.
to buy a house or maybe even to roam around,
Yeah.
what are
Nice.
the better ways to roam around. But so for that, like for a engineer who already has a location itself, so they might have a geo polygon already with them, so they have the ability of uploading a polygon which they have. So if someone like me who is not engineer itself, I might just go ahead and drop my coordinates for my house itself and start analyzing, or either just enter a location of a city that I want to analyze. For example, let's just go with Washington then, and I can just go ahead to Washington, and the dashboard itself gives you the ability of drawing a auto create polygon. So the user has the ability of drawing their own custom polygon if they want to just select their house and they want to draw it, or they can just use the auto create polygon to draw the polygon for the whole Washington area itself. So let's just dive into it. And now if you see, like, there's a 3-step process to how heat map creation is done over the
Nice.
dashboard itself. So the first step was to actually get the polygon in place. The second one is to select a time frame that you want to generate the heat map for. So right now we have like 3 different time frames that we can generate the heat map for. So that's single hour, range of hours, and single day. So for single day, you have the ability of generating a heat map for a whole day. So it starts from 12 a.m. and ends at 11:59 p.m. Similarly, within that day, if you want to analyze a few hours, like rush hours, like being in the evening, you can analyze those. Or within a single hour itself, we can analyze everything. And there are 3 different heat maps that you can make for a
Nice.
single use case. So we can go with single hour, and it's your choice, Adam, whatever you want to pick
We'll
as
pick something in Jan then. Jan first.
maybe your New Year's there
Yeah.
next time.
Took up time as well. Let's say
Okay.
go with 3 p.m.
So according to what Adam has picked, so 1st Jan 2024, 3 p.m. the heat map will start from 3 p.m. and end at 3:59. So whatever data we are using to create the heat map will be constrained to that time frame itself. So
Nice.
moving up to the third step, which is the last step of creating a heat map, which is the tile size. this makes the granularity of the heat map itself. So it depends upon the user how they want to dissect the heat map, how granular they want the data to be. So right now, for what the dashboard offers us is like three different granularities: 60, 80, and 100 meters tile size. So if someone wants to analyze very small intricate areas of the city itself, they can go with 60 meter. And if they want to have a larger, broader prospect of the area itself, they can go with 100 or 80. So
Nice.
right now, I think we can go with 100 itself or 60.
We'll go with
Whatever.
60.
We'll go with 60. Okay.
You don't have to argue now.
Okay,
No, no.
we'll go with 60.
Whatever Adam decides. So
Sure, we're going with 60.
so once we now we send the data back to the backend itself, and I think Amir, you can talk more about how the magic happens on the backend.
Okay, absolutely. Let me take you through the underlying models that we utilize. So the models that we use is the LTM, which is the large temperature model. The model tries to make sense out of the temperature data and tells the user a story. So what we try to do is we use the different data sets like satellite data, weather station data, IoT devices, and etc. All of this data is compiled and processed so that we can extract certain features out of it.
Nice.
Now, some of these features are taken to context, temporal, spatial, atmospheric, and environmental factors. So once these factors are extracted, the data is used to transform it into different temperature data points. Now each temperature data point is different from other because we dive deeper into each of its features. So it provides us with the deeper granularity that we require to represent it in terms of a heat map. Now to interact with the heat map, the front end needs to be easy to use and intuitive. So Snehal can take us through the front end and how he has developed it into it.
There's a lot of pressure on you, Snehal, today.
Indeed. So now that the heat map is developed and we get all the data back from the backend, and this is how we render it on the front end itself. So the user sees the heat map on their screen and a temperature legend itself. But now, if someone wants to actually control and change how the heat map looks and they want to play around with the heat map, so they can go into what we call map controls. And here we offer similar functionality as other GIS platforms. So this is again more intuitive for easy use. We have not complicated a lot of things here. So if the user wants to change how the heat map currently looks, there's like different color ramps, like we call it color ramps. Looks give different kind of analysis to a heat map itself. So right now, I think we can go with red, blue, 10. Adam was already hovering over it. I think he wanted that only.
I think what I truly like is that within 1 hour, you're able to capture a lot of temperature difference. But what I actually truly like is, we've been receiving weather data saying, DC is, I don't know, 22 degrees Celsius for 1 p.m. And that's so much sequential because even if they were giving us 2 p.m., they would say, it's still 22, and the chances that it changes to 23 probably are 10%. And they continue to do this for the entire city. Now, what I see is that you guys are presenting temperature data, and only a few kilometers apart, you can capture all the difference. So we're not only looking at a range of difference in temperature across the entire map, but you can capture, because there are hot spots and cold spots, you can capture the difference even within, few kilometers apart, within the same hour at the same city.
Yeah.
And this is, I feel like this is really quite interesting because the models now are bringing a lot more truth to the understanding of data at those human levels. Because why would I want to know what's the temperature at those atmospheric levels when I want to know it where I'm walking, I'm living, where I'm doing business and conducting, probably industrial activities and different other things that I want to extract from the ground, right?
Yeah,
That's true.
exactly.
So even as you mentioned, like how granular, like how temperature is changing, we could see like temperature range right now. It's like the minimum is 17.45 degrees and the maximum is like 21.28 degrees. So within the same city itself, we see a lot of temperature difference, which is
The same hour.
yeah, within the same hour itself.
I really can't imagine how much this model can do to for a week or a month or a season or even a year time of understanding those temperature differences near surface levels.
I would also like to point out that the accuracy of the model is also something we put a lot of our uh, time and effort into. So what we try to do is we try to test it with all of the real world data that we collect from weather stations and different possible scenarios that can occur in different seasons or different time conditions, so that we have a large period of time where we have tested and trained our model for. So that also accounts for all of the variability that you see in the heat map.
Nice.
So moving into the map controls itself, so we have the ability of changing the number of classes which are there. This is how we divide the temperature legend into. So we can divide it into, like, it was starting at 10 right now, and if we divide it into 6, the same range will be now calculated and divided into 6 different classes. So we
Nice.
see the same heat map but now recalculated with 6 different class ranges. Now, and even we offer like different class modes which are there. Currently, like the one applied is equal class, and we can start with equal interval, where the intervals are now will be of the same difference for across the heat map. So if you see, like, the difference now within the temperature legend will be the same across the whole thing, and you can increase the number of classes as well. Yep. So once this is done and you are actually satisfied with the result, and the user actually wants to go back to it sometime later in the future, and they want to close the dashboard and they come back to it, we have the ability of saving controls as well. So whatever you have done, whatever you have played around with map controls, you have the ability of saving it, and whenever you retrieve the heat map again, the same controls will be applied, so that you don't have to go ahead and examine it again. So you will have the same controls there. So moving on to layers, this is actually my favorite part, because like you have the ability of downloading the heat map itself.
Nice.
So once you have visualized everything and you're happy with it, and you can't just take if you don't want to take your laptop away, you just want to take a copy of the heat map itself. So you can download the heat map layer, what we call, and once that is downloaded, you have the temperature legend alongside with it and the metadata. So like it will show you where did you create the heat map and what time frame did you use, and you'll have the whole data for that, and you'll get the heat map as well. The next is like the polygon layer which you saw. The polygon layer is like some for example, like I even told you, like you can make your own custom polygon there. And if you made a very custom if you made a custom polygon and it took you some time and you actually want to save it, you can just download it, and the next time you come onto the platform, you want to have the same custom polygon, you can go to create a heat map and just upload the polygon itself.
That would be a nice feature. Yeah, especially for engineers, I guess. That would be really useful. And I can see that you can control the visualization, right?
Yep. So if we change it to like satellite view, Adam, if possible. And if someone, like, now you talked about engineer, that's actually a good transition to it. If someone, like, this heat map is an overlay on the map itself, so if we decrease the opacity, we can actually target the areas that we want to actually examine. So we
Nice.
can see how the heat spots are there in the heat map itself, and we can reduce the opacity and check for that particular location, and we can see like the road networks being there, and it might consider to like how high traffic is there, which might lead to a lot of higher temperature ranges coming up.
It's interesting how organically you can just see how a park is probably cooler and how a populated area with a lot of probably roads and housing is hotter than the other areas.
Like right now, even the cooler areas, you can see like some kind of park or a garden there, which will indicate like obviously this should be on the cooler region side. So I think for the map controls, this is how you go around analyzing the heat, playing around with the heat map. And now to analyze and extract data from the heat map itself, I think, Adam, you can go ahead with the analytics part.
Cool, I'll go ahead. So now that we've sort of looked at visualizing what the temperature is in the area, I think the next step would be to understand what exactly is happening, to get a bit more information about, like, oh, in terms of numbers. This might be something which is more interested to someone who wants to make certain decisions. I think data is super important when you want to make any sort of decision. And this is sort of like the underlying like fundamental understanding of like the feature as well, is basically giving the user enough information so that they can make an informed decision based on temperature.
Nice.
So let's jump into it. For right now, we are providing them different graphs, a bit of heat map statistics as well. Talks a bit about the maximum, minimum, about this thing, about the heat map. We also sort of show the user the distribution, so it sort of the user is able to understand how the heat is sort of distributed across the heat map that they've actually created. So that now in certain scenarios, there might be some people who might not be able to understand the graph properly. So we have given observations below as well, which just translates what the graph is conveying to the user, but in just in simple words. So we have the same again throughout all of the different graphs that we have present on the platform.
I think this feature is it could be extremely useful for, we have in a lot of cities now across the US, chief heat officers and, resilient directors and city managers and different engineers who work for different municipalities and agencies who are really trying to understand the data itself, right? It's not the visualization part, which is probably the end user is interested in, and the decision maker would like to take that data and understand how is it overlaid on a map, but they really want to go through the data itself and understand like all the details associated with it. And I think this observational exercise that you just explained is something that would resonate with a lot of engineers.
Yeah. And even on that, we do understand at the moment right now, we're just showing temperature data, but we will be looking at expanding this even further.
Nice.
One of the things that even was mentioned by Amr was about how different parameters essentially affect temperature, and we understand that as well. Maybe being an engineer, you would want to sort of go to the site itself and maybe try to better understand why is it exactly hot in that area. And we sort of bring that feature directly here. So instead of an engineer going to the field, we now will be able to open a street view within the same location that you actually are interested in, try to understand, what exactly is how the area is built up, if there's greenery, if there's shade, all of that sort of information. And what you can also look at doing is capturing the street view. And what we do is we employ models on the back end which better segment and understand, give a detailed explanation to the user. So I'll
Man, I
give it
love this
to
because the traffic in DC is insane sometimes. So, just to be able to digitally just walk around DC and be able to examine the site from your computer, this is something insane. This is great.
So, I mean, now that we're doing the segmentation, I'll maybe leave it to Amr to maybe discuss a little bit about like the segmentation itself.
Sure. So the underlying models being used in this case is the semantic segmentation models. What they really do is they use each and every pixel in the image and look at the features and try to grid it across a spatial grid and trying to understand each and every single pixel, break it down and extract features from it that correlate with each other. And what happens is that when they find similar pixels to each other, they group it together. Now, this grouping can then be translated into segmentation labels and understood which segmentation label corresponds with either, let's say, a street or a road, a particular building or greenery or grassland, etc. So this then gives us a proportion, an idea of how much of the area is urban, how much of it is green, and what can be then further done on it.
Yeah.
Nice.
So, I mean, just to examine the results as well, the pathway that we've chosen at the moment right now, it's purely just built around buildings. You really don't see any sort of greenery whatsoever. Let's hope that the back view has something. And exactly, yeah. So you will be able to see certain greenery right here, but even then, pretty small. If you really look at the segmentation, it just says it's about a 5%, which is super low. Now, we are also going one step ahead and trying to give a understanding to the user based on all of this information that they see. Uh, we'll probably, hopefully, the next time when we speak, there'll be some surprises that we'll probably be showing. But at the moment, right now, we are giving a sort of a write-up to the user so that they understand, in terms of words and even in terms of the numbers that we're giving, why is it exactly hot, or what exactly defines the temperature in that area with all of the things that we're doing.
Nice. I like this. I think what's really interesting about this segmentation is that we took the Google Street View. I mean, we're a Google accelerated startup, and then we basically provide the whole value chain, right? So associating that exercise, and this is where innovation comes, like the enhancement of existing functionalities. We brought this functionality with our temperature mapping, with the models that we have, with the segmentation that you guys seems like you worked so much hard on it, and then put it on the dashboard, which you guys as well at the front end made it possible to correlate this whole thing together and bring an information understanding to the user so they can understand basically why is it cold, why is it hot, and take it through reports so they can communicate the information as well, like you were showing in terms of like analysis and different insights that they can extract from all of that information. I just love this. Yeah.
Yeah, I mean, along the same lines, we mentioned about like like an engineer visiting the site itself, but we do understand that in certain scenarios, maybe you might need to do the segmentation on a top-down level, and this is why we sort of provide another segmentation as well, which we call as the satellite segmentation. It's very similar in terms of the overall exercise with what we do for the street view, but this again is on a much higher level, top-down view of the satellite from through the satellite itself. Uh, Again, we'll go very quickly over it as well.
So it's like a 360 understanding of the whole area segmented, right? So whether they want to do it horizontally or vertically, you guys can capture all scenarios and be able to communicate that information again from the fingertip of their desktop, right? I think that's really fascinating.
A good point I would like to point out is that the underlying model in this case is fine-tuned for satellite segmentation. So what is done is it's been trained with additional data for satellite views, aerial views specifically, to extract this information from it. So just for knowledge.
Similar exercise here as well. This time around, we sort of look at the solar irradiance as well, because this is something that we can really look at when you're focusing on the satellite.
That's when
view.
the main source of energy is like the solar at that area.
Yeah. And again, we give the write-up as well. Uh, Again, now just to go over and continue with the demo as well. Another thing that we're looking at incorporating into a different feature as well, but at the moment right now with how we have it, is what we call as the environment parameters. As mentioned by Amr, quite a lot of other different parameters basically affect temperature, and one of them is the environmental ones. We do understand that if you want to make a decision, you will need to properly understand maybe the humidity in the area, and maybe has it rained at that certain time. All of the different parameters is basically what we look at presenting in this feature.
Which is information you discussed that it is considered or factored into the models, right?
Yes, definitely. And it's also a factor that sometimes the temperature is actually at that place and what the person feels is very different.
Nice.
So it's important to understand some of the thermal comfort indexes which we have included in this.
Yep. So yeah, again, we will be. This is an area where we're obviously continuously expanding, and literally on a bi-weekly basis, we're looking at adding even more parameters, not only to our models, but even to the information that we actually present to the user on the front end.
Nice.
Now, yeah, besides this, we'll be going into some other smaller features, but again, they're super powerful and super interesting. One of them is even my favorite, but we'll go over them. At the moment, right now, we have the heat map metadata, so the user can see all of the information about the heat map. Another one is the heat map accuracy. Now, at the back end, I don't want to, like, I mean, it was mentioned by Amr, but essentially on the back end, we're looking at fusing a lot of different data sets. And from our side, we've come up with a sort of like a table accuracy, which talks about how we sort of scale and determine how accurate the heat map is. At the moment, right now, we see the most ideal scenario where we sort of use all of the important data to actually come up and create this heat map. But we do acknowledge the fact that there might be certain times where we might be lacking certain information or data to actually create the heat map. So we want to make it very clear to the user that the data or the heat map that they're actually looking at is perhaps created from this set number of data sets, and maybe not everything that, which makes it the most accurate.
Yeah, I mean, in the data business, transparency is probably at the core of delivering information. I really like this feature. This is really great.
Cool. And yeah, besides this, we have a couple of other ones as well. We have a chatbot, so if in case if there's something that you're maybe running into an issue, you can look at doing like asking the bot itself. It's pretty convenient instead of reaching out directly to us. We've sort of worked a lot on this so that it can help out a lot of the users who are actually using the platform, and we'll continuously keep on improving it as well. Besides this, we come down to the activity history. So again, when we actually come onto the platform, you want to maybe create heat maps for different locations. In the end, every single thing sort of comes down to this. We keep similar to how the existing platforms are. We look at having a history for the users so that they can look at going back to them at any time. Now, I might just pull up another heat map that I've created before. Let's say for Houston, Texas. What this will do is it'll load up all of the different settings that I've applied for the heat map. It'll also bring up all of the analytics that I've also done for it. So it makes it super convenient, super easy, and you're able to just pull up any heat map as
So
at your fingertips.
when you say like all the settings, I assume here you have some settings because the map isn't showing in full colors, right?
Exactly, yeah. So obviously we can again go back to changing the map controls as well. But if you notice previously, the heat map that we've created was in a different unit system. Right now, if I go here, uh, one thing that we understand is that everyone from different backgrounds would have a different measurement system. Right now, what we have is the kilometers in Celsius. But if someone wants, we can probably go with the imperial system, which is the miles and Fahrenheit, or you could just go with the metric system.
I still don't understand why is this your favorite?
No, I mean, being a science guy as well, I think it's very makes a very big difference with the different type of system that you're actually looking at, with the different ranges, the sizes as well. But yeah, this is another one as well. Uh, and yeah, the very last one is our feature update as well. Right now we have the beta version. We will be continuously updating the patch notes and obviously smashing different bugs, releasing different features, and just overall making a lot of improvement even on the backend side of stuff.
Nice.
So
I assume a lot of people are going to be using this, and maybe we want to talk about the feedback form because we're seeking feedback, right? We just want to improve this, and I'm sure that there are a lot of folks out there who wants to help us improve the dashboard. Since it's, I'm going to talk about how we're going to roll it out as a freemium. So how do we use the feedback form?
right. So when you're actually using the platform itself at any single given time, if there's maybe an issue that you run across, or maybe there might be something that we could better improve on, or maybe a feature that you'd maybe like to have, you could sort of click on the feedback form, the button, which is always available to you, regardless of whatever you're doing on the platform. Select the subject that you want to do. Maybe it's a bug, maybe a UI feedback, a performance issue, or maybe just something else altogether. So you could just look at new feature suggestion, uh, and then essentially you can just write a complete description about what it is. And if you want to maybe include a screenshot of what you're exactly looking at, this will sort of help us better understand what your feedback is, so it sort of contextualizes it. But yeah, essentially, maybe you can say new class types, right? Or new map types, essentially. Uh, and then you write this, include a screenshot, and then just submit, and yeah, then we'll basically get an email, and then we can follow up with this.
All right, this was great, guys. Thank you so much for making it simple as well. That was really great, and I'm super excited because we're gonna roll out this as a freemium, right? So anyone can use it, and they just need to join the waitlist because we're doing this in a staged manner, and we're obviously welcoming all users, and hopefully within a month everyone can subscribe to it. We already have a huge amount of users on the waitlist, but obviously we want to accommodate everyone. Performance-wise, we want to deliver faster. It's a freemium because we want to speak to the mission at FortyGuard is to democratize the use of temperature, and I think this is how or why we're bringing it to a freemium base so everyone can use it. And there is a paid version, but this is for engineers and organizations who would like to explore further how they could do with no limitations, all the features and all the analytics and all the intelligence that they can extract out of the dashboard. I mean, I give you guys a lot of credit because it's like almost every week we have something new coming, and you guys are all head down just working on making this dashboard the greatest experience or the greatest product anyone could use. So I'm excited to see this in the hands of engineers, urban planners, engineering consultants, landscape architects, I don't know, public health officials, but even individuals who just want to understand, like I did when I started the company, where to live and what house to buy, and how is this going to affect their energy, or improve, like you said or talked about, the human thermal comfort they want to choose a place for their children themselves or the vulnerable people in their families to live in a place that provides comfort to their health. So thank you so much, guys. That was fun, wonderful.
Yeah, and this is just the beginning. So, you know, a lot more to come in the future. And yeah.
All right, we'll see everyone soon.